Have you ever stopped to wonder about the little miracle that happens every single day? You grab your phone, tap on a video of a cat playing a tiny piano, and bam, instantly, the video starts playing. It traveled from somewhere far, far away, across oceans and continents, and landed right in your hand in less time than it takes to blink. It feels like magic, doesn't it? But it's not magic. It's a wonderfully clever system of boxes, wires, and invisible waves. We're going to pull back the curtain on this amazing trick. We'll follow one friendly character, let's call her Mia, as she discovers exactly how the internet gets from the big, wide world all the way to her cozy living room. Mia loves watching videos about space. One evening, she decides to watch a documentary about the Andromeda Galaxy. It's easier than you think, you know. The very first stop on our journey out of Mia's house is a company she pays every month. This is her internet service provider, or ISP for short. You probably have one too. Comcast, Verizon, AT&T. Think of the ISP as the company that owns and maintains all the major highways, main roads, and delivery routes in the giant city of the internet. They dig the trenches, lay down the massive fiber optic cables that form the internet's backbone, and make sure all the traffic flows smoothly. Without an ISP, Mia's house would be like a home on a deserted island with no roads leading to it. She wouldn't be able to send or receive any letters. The ISP connects Mia's entire neighborhood and millions of other homes. This connection might be a physical wire, like a coaxial cable, the same kind used for cable TV, or a super-fast fiber optic line made of glass. In some more rural areas, it might even be a wireless signal beamed from a nearby tower or a satellite dish on the roof. No matter the method, the ISP is the gateway. It's the on-ramp to the information superhighway. Now let's zoom back into Mia's living room. Tucked away on a shelf near her television is a small, unassuming box. This is the modem. If the ISP provides the road to her house, the modem is the official mailbox at the end of the driveway. Its one and only job is to communicate with the ISP. It speaks the ISP's network language. The signal from the ISP can come via a cable, via fiber, or via a phone line. That signal isn't directly understandable by a computer or phone. The modem's job is to translate. It converts the incoming signal into a standard digital format devices can use. Imagine the ISP sends Morse code over a telegraph wire. Maya's laptop reads only English. The modem is the telegraph operator in her house. It listens to dots and dashes and turns them into plain words, digital data. It also works in reverse. That process is called modulation and demodulation, hence modem. One port connects the incoming cable from the wall, the ISP link. One other port is the Ethernet port for a cable going out. That outgoing cable carries the translated, usable internet to the next device. The modem doesn't route traffic inside the house, it just converts. It's the bridge between the outside network and your home network. Right next to Mia's modem is another box, this one often with one or two little antennas sticking up. This is the router. If the modem is the mailbox that receives all the mail for the house, the router is the person inside who sorts that mail and delivers it to the right person. Mia lives with her brother, who is in his room playing an online game, while her mom is in the kitchen looking up a recipe on her tablet. All three of them are using the same internet connection at the same time. The router's job is to take this single, powerful stream of internet from the modem and intelligently share it among all the different devices that want to use it. The router creates your own private network inside your home. It acts like a traffic cop standing at a busy intersection. When Mia's request for the space documentary comes back from the internet, it arrives as a flood of data packets at the modem. The modem passes this flood to the router. The router looks at each packet and sees that it's addressed specifically to Mia's laptop, not her brother's gaming console or her mom's tablet. It then directs, or routes, that traffic only to her laptop. At the same time, it's directing gaming data to her brother, recipe data to her mom's tablet. It keeps all the traffic organized and prevents it from getting mixed up. To do this, it assigns a unique local address to every device that connects to it. Think of it like giving each person in the house their own room number. This local network is also a great security feature. To the outside internet, all the traffic looks like it's just coming from one place, the router. It hides the individual devices, making it the device that creates the Wi-Fi signal. Now for the part that feels most like magic, Wi-Fi. The router has created the home network, but how does the internet signal get from the router to Mia's laptop without any wires? The answer is radio waves. Same basic tech that brings music to your car radio. It's what brings the internet to your phone. The router is a tiny, sophisticated radio station. It takes the digital data, the ones and zeros of Mia's documentary, and encodes it onto radio waves, then broadcasts those waves in all directions through its antennas. Your laptop has a tiny Wi-Fi adapter built inside it. Your phone has a tiny Wi-Fi adapter built inside it. Your tablet has a tiny Wi-Fi adapter built inside it. Your smart TV has a tiny Wi-Fi adapter built inside it. That adapter is a miniature radio receiver and a transmitter. It's constantly listening for the router's specific radio signal. When it picks up the signal, it does the opposite of the router. It decodes the radio waves it receives, turning them back into digital ones and zeros, which show up as a video, a web page, or a photo. It's a two-way conversation. When Mia clicks a link, her laptop's adapter encodes that request onto a radio wave and sends it back to the router. That's why Wi-Fi has a limited range. The signal gets weaker the farther you move from the router. Walls, floors, furniture, even a large fish tank can weaken the waves. We've seen the path from the ISP to the modem to the router and through the air to Mia's laptop. But what is the stuff that's actually traveling? The video of the Andromeda Galaxy isn't sent as one giant file. Instead, the internet breaks everything into tiny pieces called packets. Think of it like mailing a giant encyclopedia. You wouldn't use one enormous, impossibly heavy box. You'd carefully tear out each page, put each page in a small envelope, mail thousands of envelopes. That's exactly what the internet does with data. Each packet is like a tiny digital envelope. Inside, a small chunk of the actual data, a sliver of video, or a piece of an image. Each packet also has a label attached to it. The label shows the IP of the sender, the server with the documentary, and the IP of the recipient, Mia's router. It also has a number that tells the receiving computer the packet's order. So, one packet might be labeled Packet 74 of 1,500,000. Even if packets arrive out of order, Mia's laptop reassembles them correctly to play the video smoothly. Packet switching is incredibly robust and efficient. The packets from Mia's documentary don't all have to travel the same path. Imagine a massive traffic jam on one of the internet's main highways. Some of Mia's packets might get routed through a different city to avoid the delay. Because they are small and independent, they can travel thousands of routes across the globe at once. When they arrive at Mia's router, her laptop is like a diligent postal worker, gathering the envelopes and arranging them in the correct numerical order before presenting the final, complete video. With all this data flying through the air and zipping through wires, it's natural for Mia to wonder if her connection is safe. The answer is, it can be, if you take a few simple precautions. The router is not just a traffic cop. It's also the main security guard for your digital home. One of the most important things you can do is to protect your Wi-Fi network with a strong password. An open, unprotected Wi-Fi network is like leaving the front door of your house wide open. Anyone nearby could connect to your internet, use your bandwidth, and potentially snoop on the information you are sending and receiving. When you set up your Wi-Fi password, you'll see options like WPA2 or WPA3. These are types of encryption. Think of encryption as taking every letter you send and scrambling it into a secret code that only your router and your device know how to decipher. Even if a snooper managed to intercept the radio waves carrying your data, all they would see is a meaningless jumble of characters. WPA3 is the newest and most secure standard, so you should use it if your router and devices support it. Another critical step is to change the default administrative password for your router itself. These default passwords are well known and published online. If you don't change it, a malicious person on your network could potentially log into your router and take complete control of it. Finally, just like your computer or smartphone, your router has its own software, called firmware. It's important to keep your router's firmware up to date to protect it from the latest threats. These simple steps, a strong Wi-Fi password, a unique admin password, and updated firmware, create a powerful shield around Mia's home network. So now Mia understands the whole amazing journey. Her simple click sent a request, translated by the modem, directed by the router, broadcast by Wi-Fi. That request traveled across the ISP's network, found the right server using DNS. The server sent the documentary back in thousands of tiny packets. These packets retraced the journey, were reassembled by her laptop, and appeared on her screen as a seamless video. But what about when it doesn't? The classic fix: power cycle. Unplug both, wait about 30 seconds, then plug in the modem, wait for solid lights, and finally plug in the router. For slow spots, move your router centrally, out in the open, and higher up. Use 5 GHz when close. Ethernet for the fastest, most stable link. The internet connects us to a world of information and entertainment. Now you know how it works, from the giant ISP highways to the invisible Wi-Fi waves filling your home. 2 quick tips. Always protect your Wi-Fi with a strong password. And when in doubt, reboot your modem and router. The journey of 1,000 megabytes begins with a single click. If you found this helpful, like, share, and subscribe for more.